I wanted to point out that the presentation that I'll be talking from is available for download now at streaminglearningcenter.com. So go to streaminglearningcenter.com, scroll down to encoding, and the second handout in is, or the second article in is a download handout from per title encoding options. And click this slide or link, and then here are the slides. So you can download them now. And you probably want to download them because there's a lot of facts and figures and little details and all that stuff. So before I get started, we have an announcement from our sponsor.
Wow, thank you, Jan. I'm sponsoring Jan's panel. Now, I just wanted to do a quick reminder that our final keynote of the day will be right here in this room at 4:15, and you're going to want to attend that. First of all, we've got an amazing talk from the folks at Google that you're not going to want to miss, but also we are giving away, I think it's almost a $5,000 value of a Slingbox developer box. So that's going to be given away in this session. You got to be present to win. So you're definitely going to want to be here for that. So we'll see you guys at 4:15 here for the final keynote with Google and that giveaway. Jan, thank you so much. Have a great talk.
Thanks, Jose. Okay, once again, the presentation we're about to start on is available on my website, streaminglearningcenter.com. Go there, and if you scroll down to the encoding section, it's the second one in, download handout comparing per title encoding options, so you can download it now. It'll be up there for a while. Of course, its position will move as I add content, but it'll be up on the website forever. So here's our agenda for the next hour. This is a long session. Who here is using per title encoding at this point? Anybody? What technology are you using? Do you know? What technology are you using? Well, if you're using per title, whose technology is it? Your technology or? Okay. Okay. You know, I spent I guess 3 days at NAB, and NAB was the year of AV1, and AV1's going to be a great codec, but you know, I spoke to a lot of vendors and a lot of people who produce video, and they're not going to do AV1 in the short term because it's too expensive to encode. There's not enough players. They're very concerned about HEVC because of the royalty situation and also the additional encoding costs. And they're not going to do VP9 because they don't want to integrate a new codec into their workflow. The thing about per title encoding is if you implement per title, you get a lot of the same benefits as you do from adding AV1 or adding HEVC or adding VP9 in terms of compression efficiency without any disruption on the player side, any risk of incompatibility, any additional risk of getting sued as you might have with AV1 or VP9 or even HEVC since there's so many IP holders who aren't in pools. So the really cool thing about per title encoding is it's the simplest way to reduce your bandwidth costs or improve quality of experience by 20 to 30% with very little risk and very little development effort. So, you know, I walked away from NAB thinking, you know, all these new codecs are great, but per title is what everybody should be doing, like now. And I've been saying that for a while, and I guess the focus on codecs at NAB kind of crystallized that for me. So what we're going to do here, we're going to look at what is per title. We're going to look at some of the benefits, some I just covered. We're going to look at the universe of features so that when you go back and you say, yeah, I want to consider this technology, and this technology, you're going to understand how they work and what the options are between the different technology alternatives. Now we're going to look at 4 different technologies that I tested for this presentation. We'll see pretty detailed results. We're going to look at CapCRF, which is something you guys can do in FFmpeg or depending on your encoding tool and even in your own encoding tool. We looked at source adaptive bitrate ladder from Capella Systems. And we looked at two cloud alternatives, Brightcove's context-aware encoding and Rhythm from Euclid IQ. So I'll describe how I tested these technologies. We'll look at the results, and then we'll have a summary slide to tell you, what you take away and how you look at technologies going forward. Let's start with, what is per title encoding? I mean, since the dawn of time, anybody who's ever encoded a video file knows that a soccer match is harder to encode than a talking head. But Apple introduced a bitrate ladder in TN2224, and a lot of people just used that bitrate ladder for all videos, even though we knew some were harder to encode and some were easier to encode. So what per title encoding does is it customizes the encoding for each video file. So if you're encoding a soccer match, you use a different bitrate ladder than you would if you're encoding a talking head video. And it was first implemented commercially as per title encoding by Netflix and YouTube. Netflix came out with kind of a seminal blog post in December of 2015, and then YouTube had been doing it for a while but didn't publish any results, and they published some results in March of 2016 at a quality conference in San Francisco. The first encoder implementation came from a tool called Capella Systems Cambria encoder, and we'll look at the results of that as part of this analysis. And that came out in mid-2016. And if you want to do it yourself, as I mentioned, you can implement it yourself via CapCRF. That's something. Who's using an FFmpeg-based encoder at this point? Anybody? So if you're using an FFmpeg-based encoder or an encoder like Vantage or some of the cloud platforms that give you access to FFmpeg encoding commands, you can implement CapCRF as soon as you get home. So what are the benefits of optimizing your bitrate ladder and per title encoding? You're going to reduce your bandwidth cost, and every month when my eldest daughter gets home from college and she sits and binges on Netflix, I get an increased bill from my ISP because my bandwidth consumption goes up by like 4x. And per title encoding reduces that because it reduces the bandwidth necessary for each title. So you're going to save your customers money or save them bandwidth capacity when they download these clips, particularly on mobile. It's more efficient on networks because it's lower bit rate, and you're going to deliver a better quality of experience. Instead of sending a 720p clip at 2.5 megabits per second, you're going to send a 1080p clip at 2.5 megabits per second. That's going to look better, customers are going to be happier, and there's no bandwidth hit. On the producer side, how it affects you is you get lower bandwidth costs, lower storage costs, lower encoding costs, because you're going to cut some rungs from your encoding ladder. We'll look at that in a few minutes. If you're using fixed video pipes, you're going to have more video through those pipes, can serve more customers. Better reach to customers on the edge of the networks because it's lower bitrate video. You're more competitive because of the consumer side benefits that we talked about over here. And you're more competitive because it's something you can talk about when you're comparing against other services or types of companies that do what you do. And let's look at the evolution of per title optimization. So prior to, who here has heard of a company called Beamer? So Beamer, they'd be happy about that. Good name recognition. The Beamer sells what's called optimization. So what optimization is the ability to look at each video on a frame-by-frame basis and adjust the data rate upwards or downwards based upon the encoding complexity of that video. Now, who here still streams CBR video? Who here says, I'm not going to stream video unless it's CBR? You can probably leave now. Just kidding. But there are some producers who think it's absolutely necessary to stream only CBR. And if you look at a technology like optimization in particular, you can't use an optimization technology and get a CBR file because it's adjusting the data rate up or down based upon the complexity of that frame. So if you're looking at a technology like Euclid or a technology like Beamer or a technology like CRF, if you're concerned about delivering CBR video, those technologies are not for you. But there are options, and we'll cover those next. So in late 2015, Netflix came out with a technology called per title encoding. And per title encoding, as they implemented it, has two steps. Step one is use a technique to evaluate the encoding complexity of the entire video. The entire video. And then once you understand that, you can apply any encoding technology you want to that video. So if you want CBR, you can apply CBR. If you want VBR, you can apply VBR. So it's a two-step process: gauge complexity, apply traditional encoding technique. Very different from optimization, which looks at each frame and adjusts the data rate up or down according to scene complexity. Okay? So this is traditional per title optimization. Again, it came out with per title encoding from Netflix, operation we talked about. Yes, you get bitrate control. No, you don't change the GOP or segment length. So most people here probably use a GOP size of 2 and a segment length of 6. You don't change that for either of these two technologies. Okay, 2016, the first commercial per title encoding systems came out. And the Capella Systems Cambrian encoder did the same thing Netflix did. They gauge complexity, apply a traditional encoding technique. So if you want VBR or CBR, you can have VBR or CBR. Okay? And we'll look at how this works in a moment. In late 2017, Euclid came out with the technology that's the rhythm technology we're going to look at. And this is segment-based encoding. So they look at each segment separately, they gauge the complexity of that segment, and they encode that segment as a segment. So there's no overall bitrate control in a traditional sense. There's no VBR, there's no CBR. You can cap it. You can say, I never want this video file to exceed 4.5 megabits per second, but you can't say, give me a CBR stream for people who prefer CBR. And in 2018, Netflix came out with shot-based encoding. So what is shot-based encoding? Exactly what it sounds like. You divide a longer video into separate shots. You encode each shot separately. And we'll look at more details on that in a second. Is there overall bitrate control? No. There's a cap, but there's no bitrate control. The bitrate is going to vary. And the really cool thing about shot-based encoding is you vary the segment size and the GOP size according to the shot. So you don't apply a 2-second GOP and a 6-second segment. If it's a 5-second scene, you apply a 5-second GOP. So what are the benefits of that? You have keyframes at scene changes and not at regular intervals. And as long as you have the same keyframes in the different layers, you preserve switching. So there's no ABR problem. You can just switch from rung to rung using the keyframes in the file, because even though they are irregular, they're consistent within the variant streams. So major encoding changes are made at scene changes. So if you're going from a chase scene that you want to encode at 6 megabits per second to a close-up of the hero that you want to encode at 2 megabits a second, you're making that change on the scene boundary. You're not making it at an arbitrary keyframe within either of those scenes. So any major change in the encoding structure is not going to be noticeable by the viewer. Rate control is not really essential because each scene is going to encode similarly. I mean, the entire chase scene is going to be high bit rate. The entire close-up of the hero is going to be low bit rate. You don't need to apply a lot of bit rate control to each one of those scenes because they're homogeneous. And data rate control is kind of what makes compression ugly. And then if you're seeking through the video file via the iframes, you're seeking to the start of a shot, which people want to seek to anyway. People don't want to seek to an arbitrary keyframe in the middle of a shot. They want to seek to the start of that shot. So you get that with shot-based encoding. So what did Netflix, and this is all in a blog post you can see here. And so they reported, as compared to their previous per title efforts with H.264, in these sets of files, they got a 17.1 reduction in data rate. And if you're Netflix, that's probably a huge number when it comes to bitrate control and bandwidth costs. And it's not codec specific. So here we're seeing, 20x for ABC, 30x for VP9, and 30x for HEVC. So this technique is a technique that you can use irrespective of the codec. What are the issues? Again, if you want CBR, you're not going to get it with this technology. The blog post that I identified doesn't really cover how they do rate control. I'm guessing there's a cap because there's always got to be a cap, but there's no bit rate shaping or data rate shaping for CBR. And the other thing is you can't have it. And by that I mean no commercial encoder is currently offering this schema. There are some segment-based, there are traditional per title, gauge complexity, apply traditional encoding techniques, but there are no vendors currently offering shot-based encoding to sell to you. Something you can develop yourself. I mean, it seems pretty logical, it seems pretty straightforward, but it's not something anybody's offering. I just wanted you guys to understand how per title is evolving and where we sit today in terms of commercial implications or implementations that you can actually purchase. So the things I look at when I evaluate a per title technology, I want to understand the core, how it works, what it's actually doing to evaluate the complexity of the video file. And what Netflix does is they encode each clip hundreds of times using different parameters, and then they use VMAF to identify what the best parameters for that encoding is for that clip. So they're literally, each clip they encode and send out, they're encoding a few hundred times. Now, how can they afford to do that? Because if they save 5% in bandwidth and they ship that video 100 million times, they're going to more than make up the cost of the expense. Not something you guys can afford, not the most recommended technique, but that's how they do it. Can they adjust the data rate? Yes. Every per title encoding technology can adjust the data rate. Can they change the number of files in the ladder? So and we'll look at an example of this in a few minutes. I'm going to gauge the complexity of a talking head clip and see that the 1080p clip needs a maximum data rate of 2 megabits per second. Do I still need 10 rungs beneath that? Or can I compress that into 5 or 6 rungs? That's what I mean by reducing or changing the number of files in the ladder. If I gauge the complexity and I need 10 megabits per second, do I increase the number of rungs, making smoother transitions between the files there? Some technologies we're looking at do, some don't. Can I adjust the resolution of the rungs in the ladder? Some technologies can do that, some can't. And then the big ones for most producers and most users is, can I apply traditional bitrate control techniques? Can I do CBR if I want it? Can I do 110% constrained VBR if I want it? And then is there a post-encode quality check? Can I verify that this is going to be 93 VMAF score or more? Features like that. And then, as I said, YouTube has their own per title encoding technology, and that's neural network based. Why is theirs neural network as opposed to brute force? Because they have 300 hours of video uploaded every minute. And you can't use a brute force technique if you are encoding that load of video. You've got to take a guess, do the best you can. But for Netflix, different distribution schema, different number of clips, that they want to get the highest possible quality for each clip. So here's our contestants. Cap CRF, it's used by some online video platforms, including JW Player here in New York. And as I've mentioned a couple times, it's available in FFmpeg. You can do it yourself pretty simply. Capella Systems, source adaptive bitrate ladder. Review is available online at that bit.ly URL. Brightcove's context-aware encoding, shipped in, I want to say, December of last year or January of this year. And then Euclid IQ, we're going to look at a preview. That technology is not yet shipping, but it actually performed very, very well in the tests that I produced. So how do I test per title encoding technologies? This is there is no right way or wrong way to test anything. This is kind of just how I evolved. I basically just had a bunch of clips on hard drives in my office. I said, well, let me throw these clips at the technologies and see what they did. And I wanted to include clips like movie clips. So I've got a 2-minute segment from the movie Elektra, Tears of Steel's in here, Sintel's in here. I wanted to include clips that I thought were very easy to encode, like talking head clips. I wanted to include clips that were synthetic, like screen cams and PowerPoint-based clips, because a lot of corporations use those and distribute those. So I came up with these 15 clips. And then I encoded to this bitrate ladder. And it was just kind of an arbitrary ladder I had laying around. And there's nothing special about this, but there's 7 rungs. And I have 2 encodes for each technology. I have a baseline encode, which is non-per title, and we use 200% constrained VBR, 2-second GOP, high profile. All the work I did was in H.264. And then we have a per title encode. And the per title encodes 2-second GOP, high profile, no surprise there, and they can vary the data rate up as much as 150%, and they can take it as low as they want. And then what I do after that is I compare the baseline to the per title for each vendor. And I try and gauge how is the experience different because of the per title encodes as compared to the baseline. And that raised some challenges. The first challenge was, how do you compare 2 encoding ladders when this one, which can reduce the number of rungs in the per title encoded streams, doesn't have a 250 kilobit per second stream at 320 by 180. So some of the technologies actually reduce some of the rungs from 7 to 4. So it's like, what do you do then? And what I came up with, I'm kind of getting ahead of myself. But let's go through this, and we'll come back to that point. What I did is I encoded the baseline. I computed the VMAF score. VMAF is a quality metric that's used by Netflix for their encoding facility. That's the motor that drives their per title and their shot-based encoding technique. So I computed the VMAF score here, and I compared it to the VMAF score here in the per title encoding technology. So it's VMAF based. What I like about VMAF is it scales very well. So down here you see a VMAF of 32. Up here you see a VMAF score of 95. Down here you see 28.54. There's a very nice range. That feels good. Up here you see PSNR scales from 34 to 32. And that's kind of ridiculous, right? I mean, if the 1080p clip is a 34, how can a 320 by 180 clip be a 32? It just doesn't, it doesn't feel good. Same thing with SSIM. We scale from 0.97 to 0.92. That doesn't compute to what you see on the screen. So that's why I like VMAF. VMAF talks to me in the context of the entirety of encoding ladder in a way that PSNR and SSIM don't. And when you're looking at VMAF, 1080p maps to CRF22, which is a pretty high quality level. At 1080p, that's what a 100 score is. And the CRF, a 20 score relates to 240p at CRF28. So they basically designed the spec to go over the spectrum of the complete encoding ladder. Plus or minus 6 points should equal a just noticeable difference. Why do we care about that? Because if I see a difference here between 95.39 and 93.86, I know that most people won't notice that because it's not 6 points. If it's 3 points, I start to think, well, some people might notice it. But you know, a difference of 6, I think 75% of people who compare those two clips would notice the difference. So I like the fact that I understand how much the scores should make, how much difference the scores should make to the typical viewer. And then I added overall scores for PSNR and SSIM at the end, and you'll see what those look like when we get to the end of each technology. Hybrid is a cloud encoding platform. They're here at the show. I use them to analyze all the clips in this tutorial. Why did I do that? Because if I use the Moscow University tool, which is what I use for one-offs, I would have to, you know, I analyzed about 750 files, all between 2 and 5 minutes long. And I've got a pretty hefty workstation back in my office, but it's not that hefty, especially if you have to do it over the course of like 3 days. And with Hybrid, you can load up to 20 files. So imagine what I'm doing. I've got 2 sets of files for each clip. Each one is 7 or less. So I've got, worst case, 14 files for each clip. I can load all of those at one time, tell Hybrid to compare it to the same file. It'll compute SSIM, PSNR, and VMAF. It'll allow me to consolidate those scores into one CSV file that I can import into Google Sheets. So instead of having to copy and paste, you know, for each file, I would have to copy and paste resolution, which is, you know, width and height, data rate, VMAF, SSIM, and PSNR. So that's 6 copy and pastes for each one of those 750 tests. So I mean, it would be impossible to do without Hybrid. If you're doing any of this work and you're doing high volumes, I would recommend, you know, talking to Hybrid about it. And then, you know, we're at the very early days of per title. There's a lot of different ways to look at this stuff. This is just kind of my way to look at it. And I wanted to come up with scoring. So I moved to a baseball analogy. And you'll see what I mean in a second. But I wanted, you know, number one is when I talk about how much you can save from a storage perspective, this is the bit rate ladder for the baseline. This is the bit rate ladder for per title. This is the sum of the encoded file. This is the storage savings. So that's a pretty easy to understand number, right? It's like, this is the pretty easy to understand. 15 test clips, multiply, or add up all the savings for each clip, and you get what the total savings is, and we'll see that for each contestant in a moment. The experiential, this is where things got kind of interesting, and if you don't buy off on this, and some of the per title encoding vendors didn't, then a lot of the analysis isn't going to work for you. So what I tried to do here, so this is an example of a pretty easy to encode clip, right? So this is the baseline, and this is the per title. And the 1080p clip encoded at 841 kilobits per second. So if I just compared this VMAF to this VMAF, it wouldn't make sense because the person who would have to, the person who's retrieving at 900 kilobits per second who would play the 360p clip is actually going to play the 1080p clip from the per title encoding. So the experience, the person who's retrieving at a bit rate of 900 kilobits per second is going to improve from this score to this score. Does that make sense? Instead of retrieving a 640 by 360 file, they're going to retrieve a 1080p file. So what I did was I went with the per title encoded adaptive group. I looked at this number and I said, you know, is there a file that fits under that number? Yes. And then I looked at this number and it's what's the highest quality encode that this viewer would watch at 500 kilobits per second in the per title group. So because this 443 is less than 500, I use this clip. Because this 841 is lower than 900, I use this clip. So what I'm trying to do is I'm trying to compute or understand how the experience of the viewer changes because they're using per title technology. So that made a lot of sense to me. Didn't make sense to a lot of the, or some of the per title encoding vendors. And then I compared the VMAF of the original to the VMAF of the per title. And in this case, the overall VMAF experience increased by 17.09 VMAF points on average. And notice here that most of the savings and most of the benefits come at the lower rungs in the ladder. And that's going to be important in a few minutes when we talk about Euclid IQ. Everybody clear on what I did when I talk about experiential measurements? This is what I did. And then I came up with the concept of wins and losses. So a win was any time the experiential VMAF score was greater than essentially -3. So if the average VMAF score was 0.299 negative or higher, and there was some bandwidth reduction, then I considered that a win. Okay? Because we reduced the bandwidth and we didn't change the quality of the experience. No noticeable difference for the viewer. It was a loss if VMAF score went down by 2.99 or greater, or 3 or greater, because you don't deploy per title to reduce the visual quality of your clips, right? I mean, that's easy. You could just cut the data rate. You employ a per title technology to intelligently choose the data rate for your clips. And if you're degrading the experience by greater than 3, I call that a loss. Home runs, if you improved the experiential VMAF and decreased the data rate. So in this case, we increased by 17.09. We decreased the data rate by 18%. I would call that a home run. And then a triple is a win, meaning experiential VMAF is -2.99 or higher with a 20% bit rate savings. A double is 10 to 20, and a single is 10. Okay, so these are just, trying to find ways to differentiate technology. An error was things like you didn't meet the lowest data rate. Just because I use a per title technology, in this case, the per title raised the bit rate of some of the lower rungs. I want a 250K stream because that's what I think I need to serve mobile viewers. This per title technology increased that to 300. That means I can't serve a stream to that viewer. In my view, that's an error. It's not a loss, but it's something. And really what's interesting about this is until I came up with this scheme, a lot of the encoding vendors didn't think about things like this. So you look at a feature in the Brightcove system that says, yeah, I want a 250 kilobit per second file. Because looking at this analysis, I said, yeah, that's right. People want to ensure that they have a file at a certain level, even if we do have to raise the data rate in all other files. It's also an error if there's a jump between the different rungs in the ladder that's either under 1 or over 2. Why? Because the per title encoding technology has to create a workable encoding ladder, right? You can't have a jump from 2 megabits to 6 megabits because it's going to strand some viewers. Apple came out with some pretty simple recommendations that said rungs should be between 1.5 and 2x apart. Why? So people aren't stranded at lower rungs, and so there's not, there are visible differences between the rungs in the ladder. So I wanted to make sure that if you produced the encoding ladder, you still preserved those spacings. So it's an error if you don't preserve the spacing. And a save is anytime you cut rungs from an encoding ladder. Because why? Because you're saving bandwidth costs, not bandwidth, you're saving storage costs and you're saving encoding costs. You're not encoding as many rungs. And then some model-related caveats. I never really effectively came up with a way to deal with what happens when you increase the data rate. you're not coming up with any data rate savings, but that doesn't mean it's a loss, right? I mean, if the clip's harder to encode, you want to increase the data rate. So anybody who increases the data rate, they get a win and a single. No home runs, no doubles, just, okay, this makes sense, do it that way. And then, just understand that these are all metrics that are, I'm not trying to pick a winner. I'm trying to identify features and benefits, and all the technologies did really well. So take the analysis for what it is, not this is the best technology that'll ever be. This is technology that works pretty well according to this particular system. So here's our participants. CapCRF is in encoding mode, available in X.264, X.265, and VP8 and VP9. And what CRF does, constant rate factor, is it encodes to a specific quality level, not a particular data rate. So you say, if you apply a CRF value of 23, FFmpeg will encode to a value it considers, it'll encode to a CRF value of 23, which is a specified value. If it's a hard to encode clip, the data rate will be up here. If it's an easy to encode clip, the data rate will be here. And you can specify a cap because the video data rate has to be capped, otherwise it won't stream reasonably. And really how that works from an FFmpeg perspective is you basically say, okay, here's FFmpeg, here's the input file. Use CRF23, make sure the max rate doesn't exceed 6750, make sure the buffer size doesn't exceed 4500, and then list the output file. So pretty simple stuff. I mean, it's a very simple thing to implement within FFmpeg. Does it adjust the data rate? Yes. Does it change the number of files in the ladder? No. Does it adjust resolution? No. How much customizability is there? Not a lot. CRF or max rate. Do you get traditional bitrate control? No. Okay, so this is one where the bitrate's going to be what it is until it hits the top, and it's not going to be CBR-like or VBR-like. It's just going to be what it is. Is there a post-encode quality check? No. And here's an instance where, why do we want to reduce the number of rungs in the bitrate ladder? Because this file maxed out at 1 megabit per second, and we've got 3 rungs under 200 kilobits per second. Do we need those rungs? No. Do they cost us to encode? Yes. Do they cost us to store? Yes. So just soon get rid of them. That's the benefit of adjusting the number of rungs automatically. No data rate control, as I talked about. If this scares you from a streaming perspective, CRF is not for you. The counterpoint is, as I mentioned at the start, CapCRF is used by JW Player for both VP9 and H.264 in their online video platform. And I asked them recently if they experienced any problems due to variances in bitrate, and they said no. And they've been doing it for, I think, close to 3 years now. So it's almost a religion. Some people believe in CBR, and that's all they're going to do. And for some targets, that makes a lot of sense. Netflix was 200% constrained VBR a couple years ago, and they seem to be moving more towards a bitrate pattern that's going to look like that. And they send out a lot of streams. So obviously, that works for them. And here's the box score for CRF. And we're going to see one of these for each of the contestants. So we've got how many wins? One each time. How much storage did we save? How much streaming did we save? What was the net impact on VMAF? So the net impact on VMAF for CapCRF was 66 points average up. So I averaged the benefit for each of the clips, and the total was 66. How many files did it save? It saved 98 because CapCRF is a one-pass encoding technique. So it's very simple, very fast. Singles, doubles, triples, all very interesting. Home runs, 8. What was the effect on experiential PSNR? It was 1.54 up. Experiential SSIM was 0.00856 up. And one of the things I did for this analysis, and it's just another data point, is I looked at what's the cumulative effect on the highest quality clip. I mean, the 1080p clip is our premier clip. That's the best experience we want to provide. We hope all our viewers look at that. We want to make sure everybody looks at that and enjoys it and thinks it's great quality. So how did CapCRF do here? It reduced the data rate by minus 13%. Pretty good. And it reduced the VMAF by under, by 0.14, which means we got a 13% data rate savings from our hardest to encode clip, our most expensive clip, and we had pretty much zero impact on perceived quality. So that's a good number, but as we're going to see in a second, some of the other technologies did a lot better. Here's Capella Systems, and talked a lot about this at the start. Capella is one of those two-step technologies that uses CRF to gauge complexity and then applies traditional encoding technique to that file. So if you like CBR, this is a technology you can use. And what Capella does is it encodes the entire clip using CRF. And again, CRF encodes the clip at a constant quality level, not at a target bit rate. So if you use CRF and the data rate is 10 megabits per second, that's a pretty hard to encode clip. If you use CRF and it's 2 megabits per second, the quality is going to be the same. The data rate of the easy to encode clip is much lower, so that tells you that clip is easy to encode. So what Capella does is it runs a quick CRF encode of the entire clip and comes up with a number. But it's not an average number for the entire clip. They let you define the hardest to encode segment of the clip. So if you say, OK, 30 seconds, they use the highest CRF value for any 30 seconds in that clip as the gauge for clip complexity, overall clip complexity. So if you set that number at 2 seconds, that clip's going to be really hard to encode because there's bound to be some portion of that clip that's hard to encode and has a very high value. If you set it at 1.5 minutes, then you're extending the average out, and you're going to have probably a lower value. Whatever, you create your standard encoding ladder, and you say, OK, if the complexity value comes back at 4 megabits per second, then use the encoding ladder as is. If the complexity value comes back at 7 megabits per second, increase every rung in the ladder by 1.5. If it comes in at 2 megabits per second, decrease every rung in the ladder by 40%. And what you can also do via JSON is you can put logic in that says, if the value is low, increase the resolution of the clip, and if the lowest data rate is X, throw that rung out. So this gives Capella Systems the ability to adjust the data rate, change the number of rungs in the ladder, adjust resolution, some customizability in terms of the length of period of time you analyze, and it gives you the ability to adjust your data rate via CBR or VBR. So if you're a CBR fiend, this is a technology for you. Now, why do we like increasing the resolution? This is a very easy to encode clip. It came in at 887 kilobits per second. And instead of using 1280 by 720, Capella increased the resolution to 1600 by 900 and improved the VMAF score from 83 to 84. And instead of using 960 by 540, it used 1200 by 674 and increased the VMAF score from 73 to 76. So that's why you might want to both increase the resolution of clips and increase the resolution of rungs in the ladder and eliminate rungs in the ladder. And here's the overall score for Cambria and, well, I'm sorry, for Capella Systems Cambria encoder. The streaming save was 34, a lot more than CapCRF. The thing that was particularly impressive is we got a 27% reduction in our 1080p clip with a VMAF reduction of only 0.89. So we know it's 6 points to be noticeable. We saw only 0.89 reduction. So we got a pretty, 25% or a quarter of our video is gone. Very few people would notice the difference. That's a very significant number. So I like to think of Capella as it uses CRF the same way CapCRF uses it, except it's that two-step thing we talked about. It allows you to use CBR or VBR. And why does CapCRF had a better impact on VMAF? Because CapCRF doesn't have the traditional bitrate controls. If you've got an easy to encode clip or hard to encode clip, you're going to do better with, it kind of varies by clip, but in some instances you're going to get a better result with CapCRF than you will with traditional CBR or VBR. That's just the way it is. So that's why CapCRF does better than Capella Systems overall. Brightcove's context-aware encoding. It's a feature of the Brightcove OVP. It's free with the OVP. Pricing's not yet set for the service for Zencoder standalone. Pretty much a black box. They don't really tell you how it works. You send in a bunch of parameters we'll look at in a second, and it outputs a file for you. Very, very customizable via JSON. You choose the maximum, minimum number of renditions. You can choose the minimum and max resolution, max frame rate, minimum bit rate, as we talked about a few minutes ago, plus all the normal configuration options. You can control VBR and CBR. And here's what the JSON looked like for the custom encodes in the analysis. People who came in late, go to streaminglearningcenter.com. The presentation's already up, so you can download it there. Don't feel like you need to take copious notes or write all this stuff down. In terms of features, Brightcove can adjust the data rate as they all can change the number of files in the ladder, can adjust resolution, extensive customization, which is a nice feature, gives you bitrate control, and it can do a post-encode quality check if you want to program it in. And what we saw with Brightcove, again, 14 wins. Storage save was the highest we saw so far. Streaming save was a little bit lower. Didn't impact on VMAF, was 64, higher than Capella. Had the most home runs. Reduced the top bitrate for the 1080p clipped by 24% with a VMAF reduction of under 1 point. So again, 25% the data rate is gone. Very little noticeable difference to any viewer. And then rhythm, this is just stuff, this is how it works. It's stuff I copied and pasted from their homepage. And a lot of nice acronyms up there. But really what they're doing is they let you set the MOS score. So they basically say, you tell us what MOS score you want to achieve, and we'll do that with our technology. So MOS is mean opinion score. It's what's done in subjective viewer comparisons. We used a MOS score of 3.6, and that was kind of their. I ran all these tests. I let them do the settings for me so I could verify that they didn't customize settings for each clip. But I ran all the tests myself. The thing that's funky about Euclid as applied to these tests is that they couldn't run the two lowest rungs in the encoding ladder. It's not experimental. I guess it's a pre-shipping system. They couldn't do resolutions below 640 by 360. So I only tested the top 5 rungs. The results were very, very impressive. Things they don't do, they don't adjust the number of files in the ladder. They don't adjust resolution. Minimal customizability. You build the encoding ladder you want, you set the MOS score, and then that's all you can control. There is bitrate control, but only in a cap, so you're going to see a lot of stream variability within the streams. There is no post-encode quality check. How did they do? They did really, really well. If you look at each of the files encoded by all the other technologies, most of the savings are achieved in the lowest 2 rungs in the ladder by pushing higher resolution files into those rungs. Okay, so probably 90%, I don't want to say 90, but certainly 50% of the benefit most participants saw were in the the 2 bottom rungs in the encoding ladder. Rhythm didn't get any benefits from that and still delivered an overall positive VMAF of 46%. So once they are able to encode the bottom 2 rungs, I would expect this score to go up probably higher than any other. And they produced the highest savings for the 1080p ladder with a VMAF score of -1. So again, you've got 27% savings in a VMAF rating that very few viewers would notice the difference. So again, from my perspective, it's very, very, very impressive. And then this is just the previous slide with green were the highest scores for each technology. Everybody gets a trophy. Everybody gets, you know, we're America, right? I mean, everybody gets something. So what do you want to take from this? When you're evaluating a per title encoding technology, these are the questions you want to ask. What kind of technology is it? Is it optimization? Is it per title, gauge complexity, apply traditional? Is it per scene, as we saw with rhythm? Is it per shot, as it is with Netflix, and as I think you'll probably see over the next 12 to 18 months from commercial vendors? Can you apply the traditional data rate controls? Can you get VBR, CBR? If you're a CBR freak, big question to ask right up. Can it reduce the number of rungs that increases or decreases storage cost, decreases encoding cost? Can it adjust ladder resolutions that improves the quality of easy to encode clips? How does it impact, you know, what are the saves involved? Is it 2 passes? Is it 3 passes? Is there an analysis step? Can you specify the lowest bit rate? Can you make sure that 250 kilobit per second file is there? Can it increase the number of rungs in the ladder for hard to encode clips? And then really, if you want to test yourself, collect a set of files that are relevant to your own practice. You know, if you're corporate, include screen cams, PowerPoint files. If you're an OTT provider, you know, pick a bunch of movies. And then basically just compare the results against CapCRF. Send the files off to the service provider, get the files back, compare the baseline to the per title, and do the same thing with CapCRF and see what the difference is. Any questions? It's Yes, I covered that at the start for people who got here on time. I can go back to it. So these are the, and this is available on my website, so you can download. Good question. So for this, I haven't done any I didn't do any visual. It's just too much work. I mean, I love you guys, but Jesus Christ, it was 4 days to pull this together as it was. But I have done some consulting with some of these companies, and in those cases, I did look at the. Anytime there was like a really shocking result, I would look at it, but I didn't do any consistent. Great point. I know that Harmonic has a live system. I don't believe they're changing the bitrate ladder. I think they're just adjusting the data rate. And I want to say Elemental and maybe Mux have live capabilities as well. But I'm 100% sure about Harmonic. I'm not sure about that. I think one of those two does. I'm just not remembering which one it is. But yeah, it's a totally different problem with live.
Does CRF mode give you any illegal consecutive rendition in the sense that one bitrate is, one file size is 10, the next one is 5, which is not very good?
Yeah, there were 3 errors in the CRF calculation. So that's where the bitrate jumps were over 2.0.
How would you deal with that?
Good question. So, and I'm sorry for not repeating. How do you deal with jumps in the bitrate ladder that were excessive? You know, I kind of talked about that. I just didn't mention it when we were talking. Meaning I put it in the slides, but didn't. So this was, you know, the errors are what you're describing here. And if you're concerned about it, most of them occurred between 720p and 1080p, where the data rate jumped by 200%. I was thinking you could reduce the quality of the 1080p rung or increase the quality of the 720p rung. So just use a different CRF value and see if that fixed the problem for you. But I mean, I mean, you know, you've got to do a bunch of files and see how you know, if the difference is 2.05 instead of 2, that's not a huge deal. If it's 4, then you know, it's problematical. Good question. So what tools did I use to confirm that the GOP was honored? I used switch from Telestream. So that shows you the actual GOP size. And there was one set of files that wouldn't load into switch, and there I used media info. And you know how you can grab the FFmpeg command script used, and I confirmed that the GOP size was the desired GOP size. And I was pretty hands-on. I ran the encodes for every one of the, obviously for Capella and CapCRF, I did all of that work. Capella wasn't, I've got their software, I just run it. Brightcove set up the script, and I tested their result, and then and Euclid set up their script, and they set up their encoding parameters, and I could look at that. Say it again?
Which one did it load into Switch?
The one that didn't load into Switch was Capella. So, and then I went back and I looked at both the parameters in the file, in the preset, and also the FFmpeg, I'm sorry, the media info information.
Sorry, one more question.
It's okay.
So every one of these technologies, they all use X264, everyone uses their own encoding technology underneath. Like Brightcove versus Euclid.
I don't know. I think Euclid uses a version of X.264.
My point is, if they use different encoding technology underneath, how can you tell whether the gain comes from the decision making of bitrate or whether it's...
Oh, no, they use the same. In fact, Euclid didn't encode the baseline because they don't have that capability. So I used X.264 for Euclid. And every other technology, we use scripts to produce their own baselines. It was always so it was Brightcove against Brightcove, Capella against Capella, CapCRF against CapCRF.
I don't know why I'm drilling you more today. I'm curious, since you were using Switch, did you have to say one was better than another argument?
I'm sorry, you're going to have to speak up.
Oh, like Euclid came out better, right, with some of that like, could you ascertain whether, like, they use B-frames better because you would see in your GOPS more B-frames, and therefore that might be why they did better? Were you able to make...
I mean, Euclid's the only one where that question was raised because all the other settings were identical for the other competitors, and I didn't take it at that level. I basically said medium preset. That's what I use for the baseline, and that's what they use for the per title. So I tried to keep it as simple as possible, just to limit the variables.
Jan, do you see per title encoding coming available in a way that's more simplistic for the average user to be able to take advantage of? It seems like it's pretty involved.
Well, I think the analysis is pretty involved, but I mean this is what it takes for FFmpeg. I mean, and you could say FFmpeg is beyond most people, but I mean, if you're an encoding professional, this is, and then in the case of Capella, they have a sample script that they include with the product. So I mean, and their tech support are the ones who changed the JSON for me to get it. So it's not, I think the analysis is more complex than the implementation. With Euclid, for example, once you set the encoding ladder and choose the MOS value, it's all automatic. So there's literally no configuration dials to worry about beyond those two.
I promise.
No, it's okay. We've got time.
Do you mind going for one of the slides where you show all the bit rates you decided to compare those encoders against? And how did you come up with those bit rate points on which you compare?
So how did I come up with the bitrate ladder? It's kind of pathetic, but it was just a bitrate ladder I had laying around.
Do you think it will make the difference if I pick different bit rates? A huge difference.
Certainly, I think if you should run it through a bitrate ladder that's relevant to you. I would say that. If you've got an 11-rung bitrate ladder that it goes all the way up to 4K and you're using HEVC, I would use this as a guide and run your own tests. But
So one of your previous slides, Win was defined as a key map larger than -299 system.
half of a JND, half of a just noticeable difference. I should say there was only one loss in all the, I guess the 4 contestants, there was one loss. But it's half of a just noticeable difference was my logic. It felt like if there was, you know, if there was a negative JND and it was like 0.5, clearly that's not a big deal. So I had to kind of arbitrarily pick a number. 6 felt like too much, so I kind of settled on. And that's the thing. I mean, this is literally, you know, if you had 8 speakers talk about how to compare per title encoding techniques, everybody would come up with a totally different schema. So I'm not saying this is the only way or the best way. I'm just saying this is kind of what I came up with. And a lot of decisions were totally arbitrary. Okay, that's it. Thanks for your attention.